Here is an explanation for the answer to final exam question number 52 in Electronics Demystified, 2nd edition. If you have the printed book, please refer to page 428. We're talking about producing audio frequency energy, that's the output here, from an incoming single sideband signal and the output of a local oscillator. How do we do this? How do we detect a single sideband signal to get audio output? Well, the answer to that question is that we use something called a product detector. Product detector. I'm not sure what it's the product of. That implies multiplication. I really don't know where that name came from. Product detector. The audio is the product that we get out of it, but the output is the product we get out of anything. That's just my little 2 bits, my little thought for the day. Getting back to the subject at hand, what is it that makes this thing work? What is it that makes it possible for us to take a single sideband signal like this and an ordinary unmodulated carrier from an oscillator like that and get audio out there? And the answer is that these 2 diodes in this particular circuit do that. This circuit is called a passive product detector. It is a passive circuit. Passive means that it doesn't take any power from anything. It doesn't need a battery. It doesn't have any transistors or anything that would consume DC power. It simply operates from the signal and the local oscillator and gets its output without taking any demand on any batteries or power supplies. The way that it does that is that these diodes are nonlinear. They have nonlinearity, so they produce mixing products. What we're in effect doing, what this circuit actually is a passive mixer. We are mixing the single sideband energy here with the frequency of an unmodulated carrier from a local oscillator, and this local oscillator has to have just the right frequency. It has to have the same frequency that the carrier originally had in this signal before it was turned into single sideband. Single sideband, remember, has a suppressed carrier, but that carrier frequency still exists, and this local oscillator has to be at that frequency. So what we end up doing is mixing these 2 things here to get a difference frequency, which ends up being the output, and that turns out to be audio frequency energy. The heart of the circuit, the things that make that possible, that cause that mixing to take place, are these diodes, and the reason is because they are nonlinear devices. They exhibit nonlinearity. So that's what makes this thing work. And in this particular question, that phenomenon corresponds to choice E. So choice E is the correct answer. The nonlinearity in the semiconductor diodes, that's these things, makes it possible for this thing to work.